Hello YouTubers, doing a live run. It'll be 75 cycles of what I define as the dry graphite felt, commercially available, and it's in a circuit with a lithium ion rechargeable cell. I do supercapacitor research here at school, and I'm interested in the properties of the graphite twine and felt that I use. Nickel plated, nickel cobalt alloy plated, treatment with oxidizing agent oxone, sonication, etc. So I'm interested in the performance of the graphitic electrode material. And what I'm doing right now, as I'm showing in prior videos, I'm doing a dry cell run, and I use these yellow dummy AAs, but also the clear. These can be obtained, for example, via Amazon. And I actually like these. They're easier to pack. And you can see that I have packed it with some commercially available graphite felt. I have not cleaned it with isopropyl alcohol. I'm using it exactly as is. I'm doing a 75 cycle run. You can see the parameters. We're running a hefty 750 milliamps to charge and discharge. I'm giving it 1 minute wait periods. I've programmed it for 75 cycles. And I charge up the organolithium to 4.1 volts because I want the graphite, and in my next run with deep eutectic solvent and electrolyte lithium salt, I want to be able to see if the DES electrolyte solution will hold up at a hefty 4.1 volts. Now the cutoff I use for the organolithium battery is 3.0 volts for the cycles. So I want to see if a supercap graphite electrode with a selected DES, I'm using choline chloride urea 1 to 2 molar ratio respectively, very easy to prepare, very cheap, just to start to explore various DESs and ionic liquids. Some of the latter are very conductive, but they are not inexpensive. So, using from geometry the circumference of this cylinder equals pi times diameter, I've calculated that I would require a width of 48 millimeters of graphite felt to pack this cylinder, and a length of 28 millimeters. Incidentally, the felt is 1.9 millimeter in thickness. So I want it packed pretty snug, and I trimmed a tiny bit off, but it packed nicely, and I had continuity. Be sure you check that if you do these experiments. Make sure you have good contact there. And you can see I have it in series with the organolithium, and I have a cotter pin holding the electrodes from the AA dummy, and have it coordinated to the negative lead of the electronic load device. So I want to see with cycles if the DES and electrolyte I use will show aberrations. But this is a dry run, and I put this information, experimental data, I put it into the YouTube videos to encourage undergrads, home researchers, even professional researchers to consider using this simple pragmatic approach to testing out small samples of various DESs and ionic liquids and electrolytes. I'm using lithium tetrafluoroborate here, a well-known, well-behaved, so to speak, electrolyte in supercaps. And that way you can test out on small amounts. Oh, the mass of the felt is 0.482 grams. And with the use of this clear dummy AA, that's 3.829 grams. I will be able to see if there's any mass balance changes, particularly with the use of a DES in a wet run, which will follow. Tomorrow I'll upload the data on what I'm finding here. Thanks for watching. I'll keep you posted. Bye for now.